Hi, welcome to Talking Academia. Today I'm talking to Thomas, and it's a funny story. I'm actually talking to Thomas for the second time. Because for the first time when we recorded, it turned out our video wasn't recording. So, hi Thomas, thank you for coming for the second time.
It's good to be back. Thank you for having me again. Definitely less awkward in front of the camera the second time you do this.
Yeah, we should do it more often maybe.
Maybe the third time will be the best.
Yeah. Oh, I'm very happy you could come back. So I already know, but let's also tell our viewers, what's your program? What are you doing here in Cambridge?
So I currently have a lot of different affiliations at Cambridge. I am a member of the Statistics Laboratory, which is a theoretical mathematics-based laboratory that tries to use more theoretical mathematical methods to solve modern statistics problems. And I'm also a member of the pure Department of Mathematics, as well as the Mathematics for Information Department. So a couple of different affiliations.
Okay, and what's your PhD in?
So currently I'm doing a couple different aspects of a linguistics problem. So the main focus of my PhD is trying to figure out whether or not we can understand language better using mathematical tools. Specifically, can we understand how languages evolved and interacted with each other over time, but from a mathematical perspective by analyzing speakers today. So it's kind of like a hidden variable problem where can you take an audio file with a modern day speaker, look at this audio file and encode it in how the different speakers speak, try to understand something about how the way that we speak has changed over time. Like, is there secret information about previous generations somehow encoded in today's modern speech?
That sounds fascinating, but also sounds, to me as a linguist, sounds quite different from like what I think of when I think of mathematics. Mm-hmm. How did you end up with language, or is it really so different?
So I've always really loved mathematics, but just doing mathematics was never quite enough for me. So in my undergraduate, I did a theoretical mathematics degree, and I really loved the research I was doing and the proof-based mathematics and trying to understand this complex number system in a way that no one's understood it before. But just figuring out how these proofs worked and how different mathematical systems interacted with each other wasn't enough for me. So my entire career, I've been trying to find different applications to this mathematics where not only can I do this mathematical research, but I can feel like the research I'm doing is somehow contributing to something beyond just the field of mathematics.
Mm-hmm. Recently, we talked to another mathematician, Xenia, who moved from mathematics to social sciences. And we also talked about the social aspect of things and how that could sometimes be missing in mathematics. I feel like your project has quite a lot of social side to it, or social impact to it. How do you feel it is usually integrated, or is it easy to integrate like the social aspect to mathematics?
I think that it doesn't necessarily come naturally. It has to be a goal that you're very aware of and something that you want to do. So for instance, it's very easy to go down the rabbit hole and do a mathematics project and explore all these different aspects to the mathematics project without ever having sort of real-world application to it, unless you have the application at the front of your mind. So I think that if you have in mind that, hey, I want to look for a mathematics problem that has a real-world outlook, there are definitely those projects that exist, but you have to kind of go out and find them yourself.
Mm-hmm. And I know that your projects, you have done a lot of like real world impact projects. So I remember you did baseball project, you did wind park project. What were they about?
So the baseball project was a scheduling project where there are always kind of two different sides to the project that I'm doing. So in the real world, what I was trying to do is develop schedules for minor league baseball teams in the US so they could figure out which stadium they wanted to be at on which date and schedule their games in such a way that it minimized the travel distance for environmental reasons, for profit-motivated reasons by Major League Baseball, all sorts of different considerations.
Is it similar to the movie Moneyball, or not really?
So I actually got to meet a lot of the different Moneyball teams that exist in Major League Baseball. And the Moneyball... So the work I was doing was, for me personally, motivated by the fact that I want baseball teams to use less carbon dioxide when they're traveling to different stadiums. But from the perspective of Moneyball teams, the work that they do is often more targeted specifically towards their individual team and trying to figure out how do they make the best team with the best players to win the most games to generate the most profit. So my work was a little bit more removed from this concept of profit motivation and rather this very abstract sense of how can I be fair to all the baseball teams while reducing their carbon footprint.
And what about wind park project?
So the wind power project is a more theoretical project. I wasn't actually working with a specific wind power industry leader, but I was working from an academic perspective to demonstrate that many of the wind power plants that have actually been produced today haven't been produced as efficiently as they could be. And with basic mathematical optimization, wind power plants could be produced to produce 5% more power, 10% more power, without adding any sort of significant cost to the project.
Cool. They all seem quite different projects, like baseball, wind power, and language. Is there any contact point between those?
So there are definitely mathematicians out there who would criticize me for taking on such interdisciplinary projects, and their argument would be that if you have such a diverse array of projects, then how could you ever focus on one specific core central idea in mathematics? But from my perspective, there's so many different specialties in mathematics that unless you take a step back and you have a more holistic picture, it's going to be impossible to apply the mathematical tools we have to fully understand the applications that are available. So I know that there are definitely some depths of mathematics that I'm not as well capable of handling because I'm more of an applied mathematician than a pure mathematician. But from my perspective, I'd much rather take these different mathematical these different mathematical ideas and combine them in different ways to solve very, very different problems with a similar tool set.
Mm-hmm. Is there like a divide between pure mathematicians and applied mathematicians?
So in my experience, there's a spectrum. So there are definitely mathematicians who do mathematics just because they love the beauty of mathematics, which I completely understand, but there would never be quite enough motivation for me to do the work that I do. And then you have people like me who definitely have a very strong grasp of theoretical mathematics, but a lot of the proofs that I write are actually motivated by real-world problems. And then I'd say on the very far applied spectrum, you have computer scientists and data scientists who take tools that have already been developed and they use them for applications. So they're not necessarily looking to develop further mathematical insights, but rather they use the insights that have already been created to tackle real-world problems. Mm-hmm. But I've had interviewers before who are either very pure or very applied, and they try to push me on the fact that I've studied in both pure mathematics departments and applied mathematics departments throughout my life. Like right now, I'm doing an applied mathematics project through a pure mathematics department, and they don't see how combining those two worlds is possible, because oftentimes mathematical insights can't be forced. So it's very difficult to say, this is a mathematical problem I want to solve, this is a proof I want to write, and by the way, there's also this application that's available.
Mm-hmm. And with your project right now, what motivates you what is the outcome that you're looking for?
I think I'm motivated for both pure mathematics reasons and applied mathematics reasons. So from my perspective, essentially what I'm building is a statistical model that allows you to take a continuous function and test whether different continuous functions have been related in some sort of evolutionary method. So I'm going through the process of defining what does it mean for functions to be related evolutionarily. From an abstract perspective, what types of functions can we compare to understand this history? And how do we create these graphical tree models where you have certain variables that are unobserved? So I love the mathematics problem of looking at modern day observations and trying to recreate these historical variables, which you can't actually observe, but gaining insights into those variables based on the observations in present day. And then on the applied side of things, I think that understanding the way that we speak, especially accents of people who are less well off, is very important. Because even if you don't come from a very wealthy background where you have thousands of years of written history describing how your family got their status and how your family has changed throughout history as a member of the royal family, there's still a very valid way and very valid reason as to why you speak and the reasons behind how your speech is modified over time. So I think being able to tell the story of where different accents come from, even though those accents aren't the accents of the wealthiest individuals, is a very important story to tell.
Definitely. That's fascinating. With these tools, can you also predict how accents would change in the future?
So unfortunately, the tools that I'm using right now can't completely predict what different accents might sound like in the future. But what it could potentially provide is a range of possible accents that could evolve out of present-day language, and then assign different probabilities to the likelihood that different accents or modifications might change in the future. So if you wanted to know whether or not a specific word might change its pronunciation from one thing to another thing, then my statistical model could give you a set of probabilities saying how closely you think it might align with one pronunciation versus another pronunciation.
How did you get interested in language? I know you said that you've always been interested, but as a linguist, it's interesting to know why. What fascinates you about language?
I think part of it is the mathematics problems that language commands. The idea that human language is so complex that even the best computer models out there still don't understand why we speak in the way we speak very well. So being able to approach it from an academic standpoint and say, hey, we still can't model this very well. How can we tackle this problem, this incredibly important problem that understands the very fundamentals of how humans communicate across cultures, and somehow turn it into a fundamentally mathematics problem is very fascinating to me. But I'm also very interested by just understanding how individuals communicate and how individuals across different cultures have had their language communicate alongside each other is very interesting. And I think one of the results that I'm expecting to see from my project, and I don't have the most concrete evidence yet, is that human language has had a lot of interactions with itself. So French speakers have influenced German speakers, and German speakers may have influenced French speakers in ways that we haven't understood even up until this point. So I think it would be very cool if one of the results of my project is that we see our cultures are more related than we think they are. Yeah.
Super cool. Do you know, or can you answer, when can we model human speech? When can computers learn to talk?
So I don't think that any computer model will ever be perfect. I think that any model that you create is always going to have issues with it. It's just a question of how well you're going to be able to represent different aspects of language. So one way that we can currently understand the way that people talk is we have these black boxes, so machine learning algorithms that basically can take someone's speech and they can turn that person's speech into written words. So computers can already take human speech and turn that speech into words. Computers have also been able to very easily process if the distance between different words. So we have a program called Word2Vec, which can basically say, we have this word, can we kind of analyze how similar or different these two words are from each other, and maybe how far apart they are in terms of their meaning, or what general words might share very similar meaning to these two words. So there are already very fundamental ways in which computers can process and analyze and interpret the way that humans talk. But I think one of the things that's missing is the ability to actually model the way that language functions. So are there fundamentally mathematical equations that we can use to represent different distributions for what potential words might sound like? So can we take these functions, model the way that someone says the word one, someone says the word two, and then based on our model, perhaps sample from it and say, this is what a guy might sound like saying this word on average, and this is what a girl might sound like saying this word on average. And to my knowledge, up to date, this hasn't been done very well. And these are the types of functions we need to understand in order to be able to trace back how human language has evolved over time.
You mentioned numbers, and now as well you brought up numbers as an example. Why are numbers good examples to use for analyzing spoken word?
So we're hoping that numbers are a good thing to use because ideally they've been very well conserved over time. So there are some words that tend to get borrowed from similar languages or get borrowed through travel or through experience or exposure or media or cultural references. And then there are other words which we hypothesize have been very well conserved, like numbers. Perhaps the way that you count hasn't changed very much because people are always taught to count in the same way, and maybe the word that you use to count isn't as culturally relevant. So hopefully if we look at very highly conserved words, we might be able to see more of this evolutionary pattern in how people speak compared to a word which might have been swapped in the last 50 years because it got borrowed from a different language.
Mm-hmm. Cool. Is your background in mathematics? You said.
Yes.
Did you do your undergrad and did you also do a master's? Did you have to do masters before coming here, or how does it work?
So, I did roughly 2 undergraduate degrees. I did one in very pure mathematics, and then I did one in more applied mathematics and modeling and statistics. And then for my master's degree, I did applied mathematics. And that brings you up until this year where I've just started my PhD, which is kind of a combination of the two.
Mm-hmm. And from mathematics background, I wanted to ask, it seems like there would be quite good perspectives in the industry and going to work. Why did you choose academia?
So I actually went off and I worked in finance for a summer, and I realized that the problems that I was able to tackle and face in academia, although they pay a quarter of what they pay in finance, are a lot more meaningful. I realized that when I went into finance and I looked at the amount of money I could make, it still couldn't get me excited about going to my job in the morning, because I didn't care whether or not I made this billionaire I was working for $500 million in the day, or if I lost $500 million for him in the day, right? His life was still going to be way more elaborate and way more wealthy than 99.99% of the population. So I never felt like I was making an impact in the world, and I was just looking at numbers on a screen, and that wasn't enough for me.
Mm-hmm. That's amazing. Yeah. And academia sort of gives you this opportunity to do more meaningful stuff.
Well, first and foremost, gives me the opportunity to really focus on the mathematics. And if I find a mathematics problem I want to work on, then I can take a month to just focus on that one problem and see if I can make progress. And I'm not being tied to some sort of eventual profit motivation. I can work on the work that I want to work on and see if anything comes of it, and then maybe worry about what the application might look like later. So I have the opportunity to sometimes take a step back from the applications and really work on the mathematics that I love. Mm-hmm. And then the other side of the coin is that I get to take on a wide variety of unprofitable but very socially important mathematics issues. So I worked on gerrymandering, for instance, in the United States, and making sure that we could prove mathematically that the Republicans in the US were in fact gerrymandering. And this is the type of problem which I was able to focus an entire summer on. But if I'd been forced to also be demonstrating some sort of profit, then I'd be working at the company from 8 a.m. to 8 p.m. and then trying to squeeze in this politically motivated rather than financially motivated problem at the end of my day. And I wouldn't have been able to make nearly as much progress as I was in academia.
Mm-hmm.
Yeah.
Fascinating. Fascinating to hear about all these applied projects in mathematics. I feel like without having studied mathematics at university, my understanding of what mathematics is, and I hope that I think other people maybe as well, is that it's very theoretical and very, I think school mathematics kind of is. It probably needed to some point, but yeah. I'm just wondering that I've met so many people who think that statistics, for example, is boring. How could, because I don't think it is, but how could this be overcome? It's so easy to think that it's so theoretical, it's so boring. How could these applications of these things, make people more engaged in this? Or have you encountered like similar way of thinking that mathematics or statistics is boring, or is that not really a thing that mathematicians do probably?
I've definitely encountered this, and there's so many ways that I think this could be improved. I'm going to try to just talk about 2 of them. I think the first thing that's very important is school leadership. Right? We need very good teachers in the classroom. We need to make sure that the teachers are passionate about what they're teaching and that they enjoy sharing mathematics with their students. Because I think it's very easy for teachers to look at mathematics as this exceptional thing that only geniuses can do, which is very damaging to students, because a lot of the current mathematics teachers I've worked with in high schools and even in undergraduate programs try to cater to the exceptional 1% and leave everyone else in the dust. And if you're in the classroom and you're struggling to understand mathematics because you haven't had tutoring your entire life, or maybe you're from a racial or gender background where people have told you your entire life you're not supposed to be good at this, then it's very hard for you to excel in a classroom where you're constantly being told maybe this isn't right for you, you're not a genius, you're not the right skin color, therefore you're not supposed to do this, right? So I think it's important that classrooms have teachers who don't just cater to the top 1% performers in the classroom and are also very excited about what they're teaching. I think another aspect of the problem is that a lot of times it's really hard for students to see a tangible, this is what I'm going to do if I do mathematics, unless they have role models that they can look up to who demonstrate what a career in mathematics might look like besides theoretical mathematics. So for instance, when I was in high school, I thought I wanted to be a doctor because I'd been to the doctor's office. I saw that doctors helped people. And I said, hey, I want to help people. I think I'm pretty hardworking. I think I could become a doctor someday if I wanted to. Let me see what it takes for me to become a doctor. I want to be a doctor. But with mathematics, it wasn't until I got to college where I realized there's a whole side to mathematics besides this very elite genius type problem solving, that they're real world problems that almost anyone could tackle if they go into the field of mathematics. That if you can get excited about these problems, even if you have very little mathematics background, it's a problem you can get involved with, right? I think that if I'd had role models in high school who had shared that there was mathematics out there that wasn't just for the genius and it wasn't just for the elite and it had real world applications, then I would have found my way to mathematics a lot more quickly. I personally didn't feel like I belonged in mathematics because some of my friends' parents were MIT professors and they were doing mathematics since they were 13, 14 years old, going to MIT every day after school to work on these projects. And they would never talk to me about their projects because they said the likes of me could never understand. So when I got to college, it took me a full year to realize that even though I didn't have parents who are currently professors at MIT and I hadn't already published a paper, I could still do mathematics if I wanted to. And I was very lucky that I had the mentors in my life to say, hey, if you want to do mathematics, there's some really cool problems that you can work on. But I know there are many people out there who have been turned away and they're never going to find themselves back to mathematics, which I think is very unfortunate.
Mm-hmm. How would you encourage someone, or what would you say to someone in your situation, like who is like basically in the same situation right now that you were in high school, or that maybe have a secret passion for mathematics, but as they're not maybe, I don't know, top of their class or something, that they feel like they're not supposed to maybe go on to study mathematics?
There are definitely some really good speakers that I could recommend.
Yeah, sure. Recommend some. Do you know?
Not off the top of my head, but I've got kind of a folder at home of different YouTube videos which I think approach mathematical questions from a very approachable means.
Cool. I'll ask you about them and maybe post them.
Yeah, no, absolutely, absolutely. And I think that these sorts of presentations are very important because it takes a very bright mathematician to explain their work without using all the jargon. Mm-hmm. It's very easy for a mathematician to say, oh, I won't be able to explain it to you because there are all these very high-level concepts you could never understand. But it takes a very brilliant mathematician to say, here are some really cool problems, and look, I can show you in 15 minutes that these are problems you could also think about if you wanted to. Anything from linear regression to different dating algorithms, which I think are pretty interesting, to politics applications, to renewable energy applications.
Yeah, I feel the same way, like speaking to you right now, because my mathematics background stopped in high school, but now I feel like you're presenting the pretty like hard concepts in so approachable way. So it's yeah, great to have that. Definitely makes mathematics more attractive.
Yeah, I hope so.
So you're in the end of your first year now here in PhD. Mm-hmm. How many years do you have left then?
So theoretically I have 2 more years, mm-hmm. but from experience of my peers, I think it might take me another 3.
That's what I wanted to like ask you about. How does it work? Like, because I was recently accepted to PhD here for a 4-year program with 3-year funding. Mm-hmm. How does it work? I never understand. Is it supposed to be 3 years or 4 years then?
I don't quite understand either. I've been told under the table by my supervisor and a couple of other individuals that if I don't finish in 3 years, they're very generous with granting extensions. And I was told under the table by Trinity when I was trying to figure out whether or not I wanted to come here that if you need financial help for an additional year, oftentimes they'll cover your tuition for you and maybe even give you a little bit of money to help supplement what you're going to live off of. But a lot of times the departments don't want to commit to it because the departments kind of have the right to make the determination, is this someone who's been here for 3 years who's going to take 1 more year to finish the PhD? Or is this someone who's been here for 3 years who hasn't made progress, who we're going to try to incentivize to leave the program? So I think there are a lot of politics that happen, but I'm very happy with the mentorship I've received here, and I'm very confident that with their support, I'll be able to finish my PhD and that they have the funding that I need in order to be able to finish the PhD. So I don't stress about it too much. I mean, it's definitely an intense process knowing that I've already got conference presentations that I need to be ready for this summer, that it's about time for me to start writing my first paper, that there are mathematics models that I'm trying to run on my computer, and sometimes they just absolutely don't work at all, and it's the most frustrating thing in the world. But in general, I wake up every morning and I look forward to exploring the mathematics that I have to work with, and that's what keeps me going.
It's great here. What's next for you after PhD?
It's hard to know. I'm very interested in potentially pursuing an academic career, but I think there are also some very good organizations out there that would let me to continue to do the type of research I want to do, with perhaps even more direct real world impact. So for instance, if someone said, hey, do you want to help us build the next $100 million wind farm? I think it would be very difficult for me to say, no, I'd rather go into academia right now. And I think there's a very high chance that those sorts of high impact projects could short term attract me directly into more of the not-for-profit world or even the government world than going directly into academia.
Cool. Good luck with that. Good luck with your research here in Cambridge and everything else. And thank you very much for sharing your experience as a mathematician. I don't think I have. I learned a lot from how mathematics can be applied. And thank you for presenting difficult concepts in an approachable way. I think it's going to attract more people to mathematics.
I really hope so. Thank you so much for having me for the second time.
Yeah, thanks for coming for the second time. Okay.
Always a good time.
That's great. Cool. Thank you very much. Thanks for watching. Like, subscribe, share. We are on Facebook, Instagram, YouTube, and that was Thomas for the second time.